This video is going to have a look at piecewise linear graphs and step linear graphs. So by the end of the video, you'll be able to classify a graph as either a piecewise linear graph or a step graph. You'll be able to construct both of the piecewise linear and step graphs, and you'll be able to analyze and interpret the graphs to extract relevant information to be able to answer some questions. So having a look at the first type, and a piecewise graph, it is a continuous graph formed by two or more linear equations, and they're joined at points of intersection. So instead of having a graph that has the one linear equation graphed on it, it's going to have two or more. So having a look at an example, we can see the one on the screen. It is actually joined by three different linear equations, and it has 2 points of intersection. Now the points of intersection is going to be where the graph changes direction. So you can see our first point of intersection is at 1 and 3, where it goes from a positive gradient to a horizontal gradient. And then our second point of intersection is 6 and 3, where it goes from that horizontal gradient and starts going back into a positive gradient again. So the graph in our example is broken up into 3 separate equations. So looking at the first segment, that has a linear equation of y equals 1.5x plus 1.5. When we are writing our equations for our piecewise graphs, we then put at the end the segment of the graph that that equation relates to. So you'll see here, it relates to when x is smaller than 1. So for when x is smaller than 1, that is the equation that relates to the graph. Then having a look at the horizontal section, our second section of the line, it is y is equal to 3, and it is y is equal to 3 when x is in between 1 and 6. So any value between 1 and 6, y is going to equal to 3. And then for our last section on the graph, our third section, y is going to equal to 1/3 of x plus 1, and that is for any values bigger than 6. So you can see that that graph, that piecewise graph, has 3 separate equations, 3 different sections all combined to form one graph with 2 points of intersections. So let's have a look at an example using a piecewise graph. The first example is a piecewise linear graph is constructed from the following linear graphs, and our equations are y equals 2x plus 1, where x is smaller than a, and y equals 4x minus 1, where x is bigger than a. So we don't know what a value is going to be, and we are required to solve the equation simultaneously to be able to find the point of intersection, and then that will find our value of a, and then to sketch that linear graph onto a Cartesian plane. So to identify our point of intersection, we actually solve the 2 equations simultaneously to identify that point of intersection. So we got y equals 2x plus 1 and y equals 4x minus 1. So we can equate those 2 equations together, and we can say that 2x plus 1 is equal to 4x minus 1. So then we can go ahead and work out what our x value is going to be. So moving my 2x over to the right-hand side is going to be 1 equals 2x minus 1. And then moving our negative 1 over to the left-hand side, 2 is equal to 2x. Divide both sides by 2. X is equal to 1. So we know the x value in my intersection point is going to be x is equal to 1. Now that I know that x is equal to 1, I can go ahead and find out what y is equal to by substituting that x value into one of the original equations. So I have chosen y equals 2x plus 1. So substituting 1 in, y equals 2 times 1 plus 1. So y is going to equal to 3. So my point of interception is going to be x is equal to 1, y is equal to 3. So that now means we can find our value to a. So when x is smaller than 1, it is going to equal y equals 2x plus 1. When x is larger than 1, it's going to equal to y equals 4x minus 1. So our a value that we would need to use to construct the graph is a is equal to 1. So now we can go ahead and complete the graph. First step is going to be marking our point of intersection. So x is equal to 1, y is equal to 3. So now I can go ahead and draw my 2 graphs from the equations on each side of my point of intersection. So my first equation has y equals 2x plus 1. So I've got a gradient of 2. So that means every time I go over 1, I'm going up 2. So I can mark in some points along that graph by going down 2 and over 1, go down another 2 and over 1, go down another 2 and over 1. So then I can draw a straight line connecting those points, and I have drawn my y equals 2x plus 1 portion of the graph. Now on the right hand side, it is going to be y equals 4x minus 1. So that means my gradient is going to be 4. So every time I go over 1, I go up 4. So I can use that to mark a second point and then join my points with a straight line. And now I've created my piecewise linear graph, where the graph consists of the two equations provided in the question. So that's an example of a piecewise linear graph. So let's have a look at the second type of graph that we're looking at, and that is a step graph. Now, a step graph is a discontinuous graph formed by two or more linear graphs that have a zero gradient. So a line with a zero gradient is going to be a straight horizontal line. And when we have a step graph, we have at least two or more of those straight linear lines coming together to form one graph. So having a look at the example, you can see that we've actually got three linear lines in our example that form our step graph. And you can see where one line finishes, the next line starts. You can tell what our value is going to be at x is -1 and x is 5, where the lines take the step up because of the points. So if it is an open point, that value is not included. If it is a closed point, then that value is going to be included. So at x is equal to -1, our closed point is down at 4. So that means our -1 value is equal to 4 and not the -1 from our open point. When x is equal to 5, the closed point is at -1. So our value for 5 is going to be -1, not the 2 value because of the open point. So that is an important distinction to remember when you are drawing your step graphs and also when you are interpreting the step graphs. So the three equations that make up the step graph, the first one is y is equal to -4, and that is between -5 and 1. And we only use our less than or equal to for our closed end. For the open end, we just use a less than sign. So that's another important distinction when you are creating and reading these step graphs. So our middle line is y equals -1, and that is in between -1 and +5. And again, our closed end, we include a less than or equal to sign. Our open end, we have just a less than sign. And our final step, y is equal to 2, and that is in between 5 is less than x is greater to or less than 9. So that is our explanation of a step graph. Let's have a look at how do we create one. And in our example, we want to construct a step graph from the following equations. So our first one is y is equal to 1, y is equal to 4, and our third one is y is equal to 6. Now for our first segment where y is equal to 1, it is going to be in between -3 is less than x is less than or greater than 2. So that means our open end is going to be -3 and our closed end is going to be 2. So we can go to our Cartesian plane, and for x is equal to -3, we can put a open dot at y is equal to 1. Then we can put a closed dot at x is equal to 2 because we're using our boundary markers from our question. And then we can join those dots with a straight line. So now doing the second step, when y is equal to 4, so going to our x is equal to 2, up to y is equal to 4, and we'll put our open circle, then putting a closed circle when x is equal to 4, and joining them together with a straight line, and then finishing off our graph with our third section, y is equal to 6, so putting an open dot at 4, and a closed dot at 6, and joining them with a straight line. So that is an example of how we can draw a step graph. So let's have a look at an example where we're applying this to a practical example using a stepwise graph. So let's have a look at how we can apply this to a practical example using a piecewise linear graph. And in our practical example, the following two equations represent the distance traveled by a group of students over 5 hours. Equation 1 represents the first section of the height, where the students were walking at a pace of 4 kilometers per hour. The second equation represents the second section of the hike where the students changed their walking pace. So it might have been that they were walking up a hill, and then for the first section, and then for the second section, they were walking down a hill. So they could walk at a faster pace. Or vice versa, they started off walking down a hill, and then halfway through they changed and started walking up a hill, so they walked at a slower pace. So the variable d is the distance in kilometers from the campsite, and t is the time in hours. So we need to determine the time in hours for which the group traveled the first section of the hike. Then we need to determine the walking pace for the second section of the hike. And then we need to determine how long they walked at this pace. So how long did the second section go for? And then we need to construct a piecewise linear graph. So looking at part A, to determine the time in hours for the group that traveled for the first section. And to do that, we can have a look at our limitation off to the side, and we can see that the time for the first equation is between 0 and 2. So that means they started at 0 hours and went up to 2 hours. So the group traveled for 2 hours, completing the first section of the hike. So moving on to part B of the example, what was their walking pace in the second section of the hike? So we're now looking at equation 2, and the walking pace is going to be the gradient. It's going back to my equation of d equals 2t plus 4. My gradient is going to be 2. So that means they were walking at 2 kilometers per hour was the walking rate for the second section of the hike. And we can see that equation 2 is for time when it's in between 2 and 5. So that means it took from 2 hours to 5 hours to complete that second section of the hike. So subtracting 2 from 5, we can tell that they walked for a total of 3 hours. So the group walked the second section of the hike for 3 hours. So now we can go ahead and we can plot that onto our Cartesian plane. Because we are dealing with time, we don't have any negative values on our Cartesian plane. So we're only looking at the first quadrant. And to be able to start off with my piecewise graph, I need to identify where the intersection points are. So to identify the intersection point, I need to solve the simultaneous equations given to us in the question. So d is equal to 4t and d is equal to 2t plus 4. So I can equate 4t to equal to 2t plus 4. So moving the 2t over from the right-hand side to the left-hand side, that leaves me with 2t is equal to 4. Dividing both sides by 2, t is equal to 2. So then I can substitute 2 into one of my equations. So d is equal to 4t. So when I substitute 2, d is going to equal to 4 times 2. So d is going to equal to 8. So my intersection point of my two equations is going to be 2 and 8. So going across to 2 and up to 8 and marking my point. So that is the point where my two equations are going to intersect and change. So then I can go ahead and draw in my first equation. When d is equal to 4t and t is equal to 0, then my d value is also going to equal to 0. So I can draw a straight line down to my 0, 0 origin, which for this question makes sense because we're looking at bushwalking and they're starting off at the camp. So they're 0 kilometers from their camp at 0 minutes. So now I can go ahead and draw the second part of my graph where d is equal to 2t plus 4. And the easiest way to do that is going to be look at what my d value is going to be when t is equal to 5. So 2 times 5 is 10 plus 4 is 14. So I can mark a point at 5 is to 14 and then draw a line for the second part of my graph. So now I have completed my piecewise linear graph to represent the distance traveled by the group of students over the 5-hour hike. So that's some examples of our piecewise graph and our step graph. Both are variations of linear graphs, and simultaneous equations can be used to help us in constructing and interpreting those graphs.